Crestchic Loadbanks is a market leader in the design, manufacture and rental of industrial load banks. We've been producing load banks for testing diesel and gas power generators for more than 35 years. Our load banks test standby generators all around the world to ensure that when called upon, they can operate effectively and safely at the correct voltage, capacity and frequency. For data center commissioning, we have a range of load bank solutions for air conditioning EAT load testing, main genset commissioning and UPS system proving. Whether it's a rack-mounted server emulator or a floor-standing load bank, a multi-megawatt medium voltage commissioning package or a capacitive load bank for leading power factor testing, Crestchic have load banks for your data center. We are delighted that you have chosen a Crestchic load bank for your power system testing application. This video aims to show you our load banks being installed and used in data centers to complete load testing and temperature testing, and to mimic the heat generated by rack-mounted servers. This type of load bank has been designed specifically for use in data centers, with consideration made for mobility and size, power rating and a digital controller. Both three-phase and single-phase configurations are available for extra flexibility. The load banks can be controlled from one central controller, with instrumentation showing individual and total system load. And with two different modes available for load control operation, the load banks can either be loaded equally with the same load on each load bank, or to apply a total load with the first load bank capacity fully used, then the second taking up the rest of the load and so on. In short, these new load banks are very versatile for your data center testing needs. In this short video, we are going to show you a typical test using 850 kilowatt load banks with both our KCS controller and our digital controller. The load bank should be placed so that there is adequate air entering the load bank's intake and the exhausted hot air going away from any other load banks and equipment. We recommend at least 2 meters of clearance for the air intake. It is possible to use the load banks in both 3-phase to a maximum of 415 volts or single phase to a maximum of 240 volts. Full capacity of 150 kilowatts is possible in both modes. When connecting the load cables to the load banks, an earth cable must always be connected to the load banks. These cables should be rated adequately for the load required, ideally being rated for the full capacity of the load banks. The load cables from the load banks can either be directly connected to the supply source or a distribution panel. Load cables should always be directly connected from the load bank to the source supply or distribution panel. The load bank terminal connection should never be used to distribute cables to other load banks. Once connections are made to the load bank, panel doors should be fully closed. A circuit breaker with protection settings should be used between the supply source and the load banks. This should be set according to the maximum load required. Where available, it is recommended that an auxiliary supply is connected to each load bank for the load bank's control circuit. If no auxiliary supply is available, then the load banks can be powered from the load supply source, providing the voltage and frequency are within specification of the load bank's control supply. These load banks have two methods of control, our KCS controller and our digital controller. Depending on the application the load banks are being used in, will depend on which controller is best suited for controlling the load banks. The KCS controller is a very straightforward method of applying loads. The digital controller has more functions, including being able to automatically perform load tests of various loads for set amounts of time, with instrumentation viewable from each load bank as well as the total from all load banks being used. When using the KCS controller, the load banks can be connected together and be controlled from one controller, or the load banks can have a controller for each one. In this demonstration, we are showing the load banks being connected together and controlled from one controller. Simply, the controller is connected into the control input of the first load bank, then a control cable connected from the control output of this load bank into the control input of the next load bank, and this is then repeated on the rest of the load banks until they are all connected. The control cables and the controller should be placed away from load cables and the hot exhaust heat from the load banks. The load banks can be loaded in two different methods. The first one we call follow. With this mode, applying a load on the controller will apply this load to every load bank. For example, if there are 8 load banks connected together and 10 kilowatts is entered into the controller, 10 kilowatts will be entered into each load bank and therefore a total of 80 kilowatts will be present on the load source. This method is typically used when conducting air conditioning heat load temperature testing as part of a data center IST, where the heat can be increased from the load banks evenly and very accurately to where they are sited. The second method is overflow. In this mode, the load is put onto the first load bank from the controller, and once this exceeds the first load bank's capacity, the additional load goes onto the second load bank, and so on. An example of this is if 400 kilowatts was applied, with each load bank having a nominal load capacity of 150 kilowatts, the first and second load banks will have 150 kilowatts applied, with the third load bank having 100 kilowatts applied. This control method is more common for rudimentary genset testing. In this demonstration, we have a 3-phase 415 volt supply to the load banks. We check the emergency stop is out. We are using an auxiliary supply for the load banks control system. Therefore, we switch the control supply switch to external. Select the loading mode. In this case, we will use follow. Then select the controller type, which is the KCS controller. This should be completed on all load banks. We can now press the start button on each of the load banks, where the cooling fans will start. At this stage, the load supply can be switched on to the load banks, and once this is present, it is possible to see the voltage on the load bank's instrumentation meter. We are now ready to apply load. We have the load bank set in follow mode. Therefore, with the 8 load banks we have connected together, we are going to apply 30 kilowatts on the controller, which will apply 30 kilowatts onto each load bank, resulting in 240 kilowatts total load. This can then be observed via the load bank's instrumentation. Other loads can be entered and applied. When removing load, simply press the clear button and will remove all applied load. Once the load testing has been completed, providing an auxiliary supply is being used to power the load bank's control circuit, the load supply can be turned off to the load banks. The load banks require a 4-minute cool down with no load present. Therefore, after 4 minutes have passed, the stop button can be pressed to switch the load banks off, and the control supply switch can be switched to the off position. The other method of controlling the load banks is with Crestchic's digital controller. This is primarily designed for using multiple load banks connected together and being controlled from this one controller. Much in the same way as the KCS controller, the digital controller is connected into the control input of the first load bank, then a control cable connected from the control output of this load bank into the control input of the next load bank, and this is then repeated on the rest of the load banks until they are all connected. Additional to this cable, an Ethernet cable also connects between the digital controller and the first load bank, and between all other load banks, using the digital control input-output sockets. The digital controller also requires an external control supply. Again, all control cables from the controller should be placed away from the load cables and the hot exhaust heat from the load banks. As previously explained, the load banks can be loaded in 2 different methods, follow and overflow. This works the same with the digital controller. As per the previous demonstration, we have a 3-phase 415 volt supply to the load banks. We are using an auxiliary supply for the load bank's control system, therefore we can switch the control switch to external. We check the emergency stop is out, select the loading mode, in this case we will use follow, and select the controller type, which is the digital controller. This should be completed on all the load banks. The following is different to the KCS control, where the load banks are started from the digital controller rather than the start and stop buttons on the load banks. We can now switch on the power to the digital controller and switch on the load supply to the load banks. Once this is present, it is possible to see the voltage on the load bank's instrumentation meter and on the digital controller. Once the digital controller has booted up, we can choose between 2 different modes to apply load. The first method is manual control. This is similar to the KCS controller in that a value is set and then applied. When going into the manual mode, all load banks will start up at the same time to the stage of ready for load. It is possible to add an optional maximum step size in this mode, so when applying, for example, a load from 0 kilowatts to 100 kilowatts, a maximum load step size of 25 kilowatts can be set so that the load is ramped up in 25 kilowatt increments to achieve a requested load of 100 kilowatts. Loads can easily be increased and decreased by inputting the new value and applying the load. Once the load test has been completed, the load is cleared and the controller will keep the load banks running for 4 minutes with no load to allow the load bank components to get down to a safe temperature. The second method of applying loads is an automatic test, where different size loads can be programmed for a set amount of time, and the digital controller will automatically change the loads according to this program. This therefore means that from pressing start on the controller until the test has been completed, the operator does not need to control the load banks, but simply monitor the test. The program can be programmed on the digital controller or can be uploaded to the controller via a USB stick. In this example, we have created a program to put 80 kilowatts on for 2 minutes, 150 kilowatts for 2 minutes, and full load of 300 kilowatts for 5 minutes, then back down to 150 kilowatts for 2 minutes before all load is then removed. You can see the operator is observing the test only, checking instrumentation and the equipment being tested is functioning as expected. Once the automatic test is complete, the load banks will shut down after a necessary 4 minutes cooldown. Once the load test has been completed, the control supply switch can be switched to the off position and the supplies to the load bank can also be switched off. Once all testing has been completed and the load banks are to be removed, the controller and control cables should first be disconnected and put away safely. Then the auxiliary supply and load cables can be disconnected and removed. Finally, access doors to the load banks should be fully shut. We hope this video has shown you the capabilities of Crestchic's purpose-built load banks for your data center testing requirements, and our versatile methods of controlling the load banks to make your tests go as smoothly as possible. For further information and inquiries, please contact Crestchic at the following website. Thank you for watching.